the yield. And again, there will be a summary table at the end that puts that all together. So let's move on to the next slide, which is yet another very nice advance in the technology, and that's what we call a packed bed. Now, packed beds can be operated, they are always reverse flow, but they can be operated either service flow up, regeneration down, or service flow down and regeneration up. Some of the nice advantages of a packed flow bed is it's simple and it's compact. In fact, you can have a lower investment cost here just because the size of the vessel is smaller. It doesn't have that additional freeboard space, and so the overall vessel is smaller. This is also the design that's going to allow the best water quality in the end, because you get such nice plug flow through the entire resin bed. There are some considerations, though, as to whether or not you would want to do the upflow loading or the downflow loading. And just to briefly mention a couple of the considerations, we can see that in the first case on the left, where we have upflow loading, probably we'll get the best absolute water quality in this particular configuration and the lowest consumption of both chemicals and water during the regeneration cycle. However, you can see that in the diagram there's a small white space at the bottom that represents the bed contracts during service, and so there's going to be a small amount of space there. And if the operation is somewhat intermittent in flow, that's not very suitable here, because the bed would relax and fall down and you kind of lose that advantage of being a packed bed. And so for those kinds of operations where you have a variable process flow or maybe a very low process flow, then the diagram on the right is more amenable, because when the water comes down from the top, it's not going to interfere when it starts and stops. Also, the downflow one can overall have a smaller footprint, because any suspended solids that do happen to enter the system will deposit on the top of the bed and can get backwashed out during regeneration. That's not possible when the resin is loaded from the bottom. And so in that case, and you can kind of see a couple little side ports on there, those kinds of systems have the ability to transfer the resin out occasionally to do a backwash, but then that involves extra equipment and a slightly larger footprint for the backwash tank. So those are some of the considerations for choosing between the different type of up or down loading. Let's move on to the final slide then in the series, which is the advanced packed bed. In many ways, this is very much like the previous slide. It's still a packed bed. The choice, though, is always service cycle up and regeneration down. The main difference with this type of packed bed is in the distribution system, whereas the packed bed would maybe have some type of header lateral system or even plate and nozzle. The advanced packed bed has this very ingeniously designed fractal header that was in fact invented by Amalgamated Research Inc., ARI. And in this particular distributor design, you can see in the lower left photograph, let's say water is entering in the hub there and has to exit through any one of the little outlet ports. The distance to travel is always uniform. So if you follow the yellow line towards a point where water would exit towards the circumference of the lateral, that yellow line is exactly the same as another drop of water that might follow the red line and actually exit much closer to the center of the vessel. And so the advantage of this is that the pressure drop is completely uniform for all of the paths, which gives the most consistent flow rate possible, so you get a very, very nice plug flow all the way down the vessel. The photograph on the right is just one of these distributors in operation, and you can see how uniform, you can call it the rain is, as it exits the distributor. And so while the water quality from this type of system is probably going to be very similar, and the regeneration ratio also very similar to the non-advanced packed bed, you can hope to get a little bit better yield in the water usage with this kind of system. So let's summarize just with the last slide, putting it all together and showing the progression as I presented it across the top of co-flow, reverse flow, packed bed, and an advanced packed bed, and seeing how the type of water quality that you get can almost be an order of magnitude better from co-flow to reverse flow, and then maybe even another order of magnitude better as you go into the packed bed operation. Silica also, you see large improvements as you move from left to right on this chart. And look at the regeneration ratio when you come to chemical costs, maybe up to 4 times the stoichiometric amount for a co-flow system drops to somewhere in the 130 to 180% stoichiometric amount range for a reverse flow system, and even slightly smaller than that for the packed beds. And yields go up, yield being the amount of water that's produced in net consumption after removing out the water which gets consumed during the rinses and backwashes and so forth. And again, as you move from left to right on the chart, away from a co-flow system, you get higher and higher yields in water usage as well. So that's the conclusion of the prepared slides I had, and if anybody has any questions, I'd be happy to try to answer them.
Yeah, I'm sure we've got questions. So let's hear the first question.
This is Tom with Mcilvaine Company with a question really for potentially any of the presenters. Regarding chlorine, for example, I think chlorine has actually been banned by OSHA and the paper industry for the pulp treatment. I'm presuming it's still a viable chemical in the power industry for water treatment, for cooling water and whatnot. Any comments on chlorine or other chemicals like hydrazine and chromates that may be being phased out and replaced with other alternatives going forward?
I guess that might be a subject for an additional webinar, Tom.
Okay. Yeah, I was just...
Yeah, if anybody has any comments they'd like to make, we'd sure like to hear them.
That's a general question for any application?
Sure, yeah.
Well, I think that the chlorine is under stress, and because of the disinfection byproducts of chlorine, so we're definitely looking at alternatives to using chlorine. Hydrazine, I think that's already bottomed out. I mean, it's a safety factor, so I don't see that changing anymore. What was some of the other chemicals?
I think that pretty much answers it. I think, is chlorine dioxide a viable alternative going forward, or is that pretty much viewed the same
right before right before we got on this call, and I had to leave another one early, we are just doing the life cycle assessment of chlorine dioxide and generation methods versus chlorine, from a carbon footprint standpoint or a efficiency standpoint. From a chemical contamination standpoint, there's a lot of advantages for chlorine dioxide, and we use chlorine dioxide as alternatives to chlorine where we're concerned about chlorination, where we have organics that are going to be chlorinated, where we're worried about trihalomethanes. So to me, chlorine dioxide's an important molecule and something that can be used with other chemistries also to replace chlorine. It's a matter of cost and consumption. So.
Yeah, this is Dan Cicero. I'd like to jump in a little bit on this too. Dave's right. The chlorine is a little bit under stress, and there are places that don't want to use it. I think it's geographic. Some states are more stringent than others. And some customers would prefer not to dechlorinate prior to discharge. So there's that. hydrazine, like I say, there are still people who use hydrazine, but they're few and far between. Another one that does come up occasionally is phosphate. There are places that don't want to discharge phosphate, and we've done research to come up with non-phosphate inhibitors to meet those customers' needs. I think that pretty much covers it.
Okay, thank you.
Good insights there. Other questions? Greg, I turned back to your slide number 8, and you said that it was equal flow was the advantage of this distributor, was it not? That you get the same amount of water coming out the end of each one of these pipes? Was that the...
Right. One of the things that can lower your service cycle, we talk about operating capacity as how much of the total capacity is really utilized during a service cycle. And when you have uneven distribution, you might see that more of the water somehow tends towards the wall or towards a certain portion of the bed, and therefore some parts of the resin bed, if you look kind of cross-sectionally down, it may not be utilized fully while others get fully exhausted. So as soon as you have breakthrough at any point of the cross-section, that's where your water quality is going to start to diminish, and you're going to have to take the unit offline. So if you can introduce the water as uniformly across the entire cross-section as possible, you have the best chance to use every resin bead throughout the entire bed to the fullest capacity. And that's what this uniform distributor really allows you to do.
And it looks like it may be a little bit more sophisticated even than having the full, the same pipe length for each terminal, that it looks like you have equal resistance. In other words, it looks like most of these have the same number of turns or bends, so that you truly are going to get equal resistance.
Yeah, exactly. And you can see also as you get, it's almost like an artery to capillary kind of effect, where there's the larger pathways leading to medium-sized ones, leading to smaller ones, and I think you're right. The number of turns and the amount of time spent in each of the different types of paths is going to be uniform throughout this. So you get this very nice equal amount of pressure drop across the whole system. So you don't see any areas where it's jetting out and other areas where it's just trickling out, for example.
So that would get the water started evenly. Is there anything that's going on within the bed that would change that so that you could still have channeling?
Well, in a packed bed, hopefully not, right? Because it's tightly packed together, so you should not see that.
Any more questions for Greg? Well, it's been a very productive session. I'd like to thank all three of our speakers, and we certainly hope that you'll join us again for future webinars. And that will end this session for today, so bye for now.